Greetings, everyone. My name is Candice Notol, and I will be taking you throughout the course Mathematics for Science. Before we can start, let me just add one thing that I think is also important. So, if you have done the course somewhere else other than here at Rhodes and you have passed it, even if you did not complete the whole degree, I would advise you to apply for credits so that you will be graded for the course. You don't have to do it again if you know that you have done it. To go about it, you go to the dean's office or student bureau if you don't know where the dean's office is, and I think they will be able to assist you there. Even if they are not able to assist you there, they will tell you where you can go to, what is the next step. So now that we have got that out of the way, why should students study mathematics for science to begin with? You will notice that most of the time, students will have some practicals. They go to the lab, collect some data. I have an example here that is similar to those that you usually have for the practicals. And suppose that you go there, or you have a pharmacist or a doctor who collected the data below from a patient, and you can see that we have time in hours this side, and we have concentration of a drug units per cubic centimeter this side. And now you are asked to analyze this data, because just because you went to the lab, it doesn't mean that you are done. These are the results. You go there, you get the results, and then when you come back, you have to analyze and see, okay, this is what I found out of what I was doing. So, what does it mean to analyze a data? In this case, because we have only two columns, which means that if you want to analyze this data, can you plot the graph? If it is possible, and you can continue to record this data. Let's say now you continue to record the data for maybe 10 days or 2 years. What do you think will be the concentration of the drug in a bloodstream? So, can you answer that particular question? And if, say, in 10 days, what will it be? In 20 days, what will it be? Your prediction, how can you predict using this data? And if you were to continue and record everything here, the question is now, will you be able to tell what is the maximum concentration and what will be the minimum concentration? Of course, and how this concentration is changing with respect to time. So to answer all these questions, which means that you should be able to find the function that actually represents this data well or closely. Let me just say that can you find the function that can actually predict this output, in other words, this concentration of a drug? But in order for you to be able to find all these things, plot and have a function, you must be able to first deal with the basics. And one of the basics is dealing with exponents and sets. So before we can begin, let's say that you have these three questions, and you are asked to actually find out what is the correct answer here. Or if it's not here, what do you think is the correct answer? So for us to actually find the solutions to this, I would like you to first copy these questions and write down your answer, the answer that you think is the correct one. Now, whether it's not one of these answers, the one that you think is correct, and then after dealing with some basics, and then you check if your answers are correct or not. Just take some time, copy this, pause the video, and then copy this, and then write your answer, and then you can continue. So, if you notice here, we have a number that is a superscript there, and we also have a number 2 here, which is a superscript there, and we also have a number that is there. What is the meaning of that number? Now, if let's say you have a number A, let's say this A is a real number, and you multiply this a by itself n times, so you have a times a times a times a n times. That we usually represent it as a to the we place this a and we have that n there to say that this a is multiplied by itself n times, and this n is given a name. We call this n an exponent, and a is called the base, and this a to the power and the results is the one that we call it the power. As an example, if we look at 64, 64 is the same as 2 to the power 6, is 2 to the exponent 6. So this 64 is the power, and 2 is the base, and 6 is an exponent. Now, how do these exponents actually work, and how to multiply them, add them, and how do we actually perform some algebra to these exponents or these powers? Now, if you have a power multiplied by the power, you always get a to the power m plus n, right? When multiplying powers of the same base, you add exponents. And when you are dividing powers of the same base, you subtract exponents. Note that the exponent that you're subtracting is one that belongs to the denominator. And of course, if let's say a is 0, remember that you will end up having 0 over 0, and that we call it an indeterminate form, or we don't know the value of that yet. We don't actually know it. And now, if let's say you have a to the power 0, you want to find out what is a to the power 0. Of course, if you want to find this a to the power 0, 0 is the same as m minus m. So when you have a number and you subtract it again, you get a 0. And if you notice that this, and using this same rule here, is the same as a to the power m divided by a to the power m, which is equal to a 1. Hence, we usually say a to the power 0 is a 1. And now, the third rule is the power of a power is the same as just taking a to the exponent m times n. You just multiply these two exponents. Now, let's talk about number 4 and why it is red in the first place. So if you have the nth root of a to the exponent m, this is equal to a. You take this m that is inside and then you divide by that n that is outside. And of course, this is the rule, right? And now, using this rule number 3 here, that you can always multiply the exponents there. We're going to apply it here, and then we take that m out and you're left with 1 over n. And if you multiply these two, of course, you're going to get that. So you get this. And of course, you know that this using this rule this side is the same as the nth root of a. And then you can have that m outside. So what this simply means, it means that you can either start by taking the exponent of a, or you can either start by taking the nth root of a and then take the exponent later. But now, is this always the case? The answer to this question is that this is not always the case, because it's not always the case. If a is positive, that will always be the case. This condition is always going to be true. But if a is negative, then you know that, for instance, the nth root, if n is even, we know that we'll get an undefined or an imaginary number. So in that case, we can say that this rule is not going to be satisfied, because this might be defined, but this is not defined. So this is only true if, whether you start by the exponent or you start by taking the nth root, we always get defined values. So as long as the nth root is defined in both of the two cases, then that rule is going to be satisfied. For instance, in this case, if let's say we had minus 5 and n was equal to 2, so in that case, this rule is not valid for that that particular case because the square root of minus 5 is undefined. You're getting it? Now, when it comes to rule number 5, we have, if you have a times b all raised to an exponent n, this is the same as first taking the exponent on a and then multiply by b taking the exponent n. And also here, you do the same thing. Having n there, it means that a is taking that exponent and b is also taking the exponent like this. And this is always true, this is always true. And of course, this is always true, that is always true under this condition, and that is always true. Number 4 is the only one that is actually having a problem. Another rule is number 7. It has stars because this is just applying the rules that are up there. So a to the exponent minus n is the same as 1 over a to the exponent n, as long as we know that a is not equal to 0. So this is also one of the rules that you can apply. As we have said that this is an indeterminate form. This is 0 over 0 is an indeterminate form, and if you have 0 to exponent 0, that's also another indeterminate form. So the actual value for this is also not known, or we can just say it is undefined. Now, what is a SAD? Before we can talk about a SAD, first of all, we need to know what is a rational number. In simple terms, a rational number is a real number that can be written in a fractional form with both numerator and denominator integers such that the denominator is not equal to 0. That's what is a rational number. And then an irrational number is a real number that is not a rational number. Simple as that. That's an irrational number. Now, what is a SAD? A SAD is an irrational number. First, it must be an irrational number. Right. And x is the nth root of some real number. So, in other words, a SAD is a rational number, but it doesn't mean that it's an irrational number, but it doesn't mean all the irrational numbers are SADs. It's only the SADs that are always irrational numbers. Now, these are some of the examples of SADs. Square root 2, cube root of 10, and square root of 27. Square root of 27, you cannot convert this to a whole number, and square root of 2, you cannot convert to the whole number, and this cannot be converted, rewritten as a whole number. So that's why it is a SAD. For instance, if let's say we look at pi. If we look at pi, pi is an irrational number, but pi is not the nth root of some number. So it's not the nth root of these whole numbers, but it is an irrational number. So pi is not a SAD in such cases. And also another thing, all SADs, as I've said, a SAD must be the nth root of some real number a. So all SADs can be written in this particular form. You can try and check if you can rewrite any SAD in this particular form. For instance, this one. Can we try and rewrite this in this particular form? Try it and see if you won't be able to have that nice thing there. Now, what are the laws? We talked about this when we were dealing with the laws of exponent, that this is only valid under the case that the nth root of a is defined and the nth root of this is defined. As long both the two are defined, then this will always be true. But if you take the nth root of a and you multiply by the nth root of b, you can always take the nth root of the product of what is inside. Take note of this n and this n are the same. We don't mean that if you have n and m, you can just multiply these there. No. We're just saying that if this n and that n are the same, you can first take the product of these two and then take the nth root. And number 3 is going to be the same, but now is for the quotient. If you take you take the SAT and divide by another SAT. As long as you have n and n, you can first take the quotient of a and b, and then you take the nth root. That's what that's supposed to mean. Now, what are the restrictions to this SAT? Now, if let's say n is odd, we don't care about the value of a. It can be negative, it can be positive. This is always gonna be defined. But if n is even, this is only gonna be defined under the case that a is positive. So as long as you have the square root, the fourth root, or the sixth root, if a is positive, then you will get a real number. But if a is negative, then we get an error if you are using a calculator, or we get an imaginary number, because the even root is not defined when we have a negative inside it. Now, these are some of the common mistakes people usually make when dealing with roots or SATs, right? Now, the rule is simple. The square root is always positive. It's not negative or positive. It's always positive. You're always supposed to get a positive answer. That's the rule, simple as that. So if you have a square root 25, square root 25 is always positive 5. It's not plus or minus 5. Simple as that. But there are some people who usually say that if you're taking the square root of 25, you're supposed to get a plus and a minus 5. That's not true. You must always get a positive 5. Now, what does that supposed to mean? If, let's say, we suppose to have a square root of a to the power 2, a to the exponent 2, this is not always equal to a. I will try and explain in a moment. Now, most people, they just assume that this root is just gonna cancel out these 2, and then you end up having an a. Is that even true? Let's double check. Suppose that my a is minus 1. If a is minus 1, minus 1 squared is going to be positive 1. The square root of positive 1, as we said here, that it must always be positive, so you're going to get a positive 1. Positive 1 is not the same as minus 1, which was this a here. Hence, we say that the square root of the square is not always the same as a. For instance, 1 and minus 1 are not the same. But if you have 1 squared, you can always get, okay, the square root of 1, and the square root is always positive, so you're going to get a 1, and 1 is the same as 1. In this particular case, this is true. So it is true when a is positive. Right. Now that we have that, how do we remove this misunderstanding? To remove that, we have a new definition that we would like us to introduce, the absolute value of a. By definition, an absolute value of a is equal to a if a is positive, right? And the absolute value of a is equal to minus a if a is negative. Take note that if a is negative, multiplying by this negative will cancel that negative, so this will be positive. So when taking an absolute value of a number, you will get a positive result. What does that supposed to mean? Since we said the square root must always be a positive number, looking between this example here, we had a positive 1, but a was negative. To get this positive 1, we need to multiply by minus 1 to get that, which is what this sign is actually doing. It's multiplying this minus a to get a positive 1. So the absolute value of a is the same as the square root of a squared. That's all there is to what we will be doing today. So just a quick recap. Go back. Just know that this course is important because you want to be able to plot, you want to be able to analyze the data that you had, and more importantly, you want to be able to deduce more information, use that information to predict the other values, and also you have these questions, and we know what is an exponent, you know what is a base, and you know what is a power. These are the rules that we usually have. At the end, we'll actually check tomorrow. We'll actually check the some of the questions to solve using these rules of exponents. That's it will be all for today. And also take note of what is a SAD and laws of SADs and restrictions and this one common mistakes, and then we end up there. So that will be all for today, and see you tomorrow.